Assalamu alaikum. I am Rehana Jamal. I am a GIS expert. I have worked in the Punjab University as a research officer and lecturer. I am working as a GIS expert and a GIS consultant also. And I am a GIS trainer, and I am recently teaching in the Institute of Geoinformation and Earth Observation in the Pir Meher Shah Arid Agriculture University, Rawalpindi, Pakistan. And today's tutorial or lab session is about the image rectification. I am going to teach about this lab, how we get an image. It is like a lab tutorial lab. I'm going to teach the BS level students in the field of remote sensing and geographic information. And I will teach today how the image is acquired from Google Earth and how it is rectified in ArcGIS software. First of all, today we will perform the first order polynomial image rectification. We will open the Google Earth Pro and take the image of any area of your study area, and you can get the coordinates by applying the edge placement marks. First, we take the 3 points for the first order polynomial image rectification. Actually, we need 3 points, minimum 3 points for first order polynomial regression, polynomial image rectification, and 4 placement marks for the second order polynomial image rectification, and 7 points maximum for the third order polynomial image rectification. But because I am teaching about the BS level students in the field of geographic information system, so I will teach them how to take the 3 points first order polynomial image rectification. We take the at placement mark first on any corner of the study area, or first we select those points which are the intersections of the roads, or the intersections of the river, or any road, or any building corner, or any edge of the building. So we will take the 3 points for this image. We will take the first point on the at placement mark. We take the first GCP on the any area, like we can take this point on this corner. We can take this in corner because this is the road junction. We can say it first GCP1, GCP1, and this is our we can add these GCPs as in the form of decimal, or in the form of you can say in the form of decimal degrees. You can take them as a decimal degrees and or decimal. These are not latitude, or you can say you can also take it as these are the decimal degrees. So now you can choose the GCPs around your study area. So for example, if you are choosing this, this is your study area, you can choose the 3 different points at the different locations. At GCP1, you can choose the second GCP here, and you can choose the third GCP at this point. So these 3 points should be scattered around the borders of your study area. Now you must take the second GCP of the GCP2, 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 and we also take this point as at this edge, and we can copy all these points so that we know that where we are going to GRF or image rectification before. And this is, for example, this is your study area, and you can take the third GCP at the edge of the road junction. Third GCP, you can take this point here, and the GCP third. You must copy the coordinates of these points also. Now 3 point. I have taken the study area for Islamabad. You can take any. This is just lab for learning purposes and level students. So now you can save these 3 points. You can make a folder, add placement folder to save all these points. GCPs, GCPs. You can add these all these 3 GCPs into the single folder. So you can save them. Now you can save all these points. You must align the north side. And now you save these points, this folder as a KML file. Tutorial-1. Tutorial-1. This is our first lab. Tutorial KMC. You can save it as KML file. Then we have to save this image also, so you can save this image also here. File was save image. You can check the legends because it covers your image and you cannot see the whole area of the image, so you must check off the title. And now you must save this image in the same folder of tutorial. For example, study area, SA, study area. Okay. Now you have to minimize this window and you must open the ARC catalog. This is the ARC catalog is the ARC component of ArcGIS software 10.5. In ARC catalog, you can view this image and you can assign the spatial reference system. Before starting the image rectification, we have to first assign the spatial referencing system in ARC catalog. This point should be remembered by the students before performing the image rectification. If you don't perform the spatial reference system, you do not perform this task. Image will not be geo-rectified easily, not correctly. So you have to perform this task in the ARC catalog. ARC catalog is the component or ARC object of ArcGIS software, where we can see the folders where your task is located. You can open the computer and the destination folder where your lab task is saved. We can find the tutorial folder, tutorial lab first. Tutorial, here is the tutorial. You can open this lab. So you can see the image we saved in this folder. Right click on this image and left click on the properties. You can scroll this window that is named as raster dataset properties, and you can see the special reference system is undefined. So you must define it by assigning the projected coordinate systems. A projected, you can check the geographic. If you want just locations of your study area, you can check the geographic coordinate system. Otherwise, you have to check the projected coordinate system. You have to check the UTM, and then you have to because this our study area is located in northern hemisphere, so we have to check the northern hemisphere. And this study area is located in the UTM zone 40, 19, 40, 43 and zone, UTM zone 43, and so we have to check this and apply this. You have to close this window. Now you have to open the arc map where you are going to perform the image rectification. So you must remember you have to assign the spatial reference system in ArcCatalog, and you have to perform the image rectification in ArcMap. Open the ArcMap. You will add that image so that you can perform the image rectification. For the image rectification, there should be known coordinates and there should be an unknown layer. The slave layer is the image, because and the our target layer is having the coordinates which we saved in the KML format. That is our master layer, our target layer, and that this image that is saved in the JPG format, it is the slave layer or the source layer. Because we are going to start a new work, we are not working in any existing map, so we have to choose the new map. New maps. We are going the first task and the blank map. Now you must add the image. I hope you will understand, all of the students of BS level of geographic information system or any other related to any other discipline. We are going into the tutorial 1. We will add this image. You can see that it has it is not georeferenced. It is just a raw map. You can see these coordinates are the only screen coordinates. These are not the georeferenced coordinates. This is a slave layer. Slave layer means we are going to add the master layer which has the known coordinates. First, we have to convert the KML layer by opening the Arc catalog. Arc catalog tools. When the Arc catalog tools, first we must save this image which we add. We have to save it in our destination folder. You must keep in mind that everything should be saved in your target folder or your destination folder. Destination folder is that folder which you are using to save your data. You must save it by its lab 1. Lab 1. You are doing first lab, image rectification. Lab 1 is about the image rectification. Now you have to convert by using the conversion tools the KML file into the layer. First, you have to convert that KML file which you saved as by the name of GCP's KML. You have to convert it because this file is having a coordinates which we saved in the form of point layer. We must save this output location. We must keep this tutorial field. We must add the tutorial field so that our output location should be saved in the form of points. We should form the okay. This camel file is converted into layer of point shape file, and you can see these. You can convert this symbol into squared or so that you can identify. You can see the point layer is separately can be seen. Just close this box, and this image, these points GCPs are not overlaid on this image. They are separate. They are separate because this image is not rectified. So now I'm going to perform the image rectification on the basis of these known points. On the basis of these known points. First, we will open the georeferencing tool by right clicking on the menu bar. We right click on the menu bar and click on the left click on the georeferencing tool. You can see the image to be rectified is shown here as SA. Now you can choose the add control points. First, you will choose the add control points. Now you must right click on the raw image and zoom to layer, and you must choose the first GCP by left clicking. By taking this tool add control points, you must left click on the add control points and then left click on this first GCP. Green symbol, plus symbol is shown here. Now you by picking this first GCP, you must right click on the point and zoom to layer. Now you must use the zoom tool and clear the first GCP, and then again you must left click on the add control point and then left click on the first GCP in the center. The image that is raw and slave image that was not rectified, it is exactly pinpoint on the first GCP. In the same way, you must pick the second GCP by taking the add control points by left clicking. You must left click on the add control point and then left click on the second GCP. Now you again right click on the point shape file and left click on to the zoom to layer. And now you again zoom to the second GCP, and you can pan this point. You can zoom and clear at clear level. You can again left click on the add control points, and in the center you can left click again. And the second GCP is again pinpoint on the second GCP of the image. Now the third, you can see there is a little bit deviation of the third GCP. So you have to again take add control points, first click on the image that is our slave layer, and then now you do not have to right click on the image to zoom to layer because the third GCP is clear in front of you. So you left click on the GCP and then again left click on the known point. In this way, all these 3 points are exactly overlaid on the image, and our image is exactly exactly rectified. This layer is not saved right now, and you can see the UTM zones coordinates in meters are shown in the slide of the in this window at the bottom right. And now you have to rectify this image that is rectified, and you have to save it. Otherwise, if you do not rectify it, this image will not be saved and you cannot open it again in the rectified format. You have to left click on the georeference tool and click on the rectify. Left click on the rectify. Now you have to choose the destination folder which you are saving this data, this image rectified, you can open the tutorial 1. This is, you must add the tutorial. You have to add the tutorial 1. Where is the tutorial? You can now this is when you click on the folder, you have to add this folder. Okay, and then the destination folder is set here. If you choose the destination folder, then your image will be automatically saved in that folder. You can change the name. If you do not change the name, it will pick the name by yours by itself. You can say this is as a geo image, geotiff. You have to choose the TIFF format because it can be opened in any graphical format. That's why we have to choose the TIFF format, tagged image file format. The priority to choose the TIFF that it can be opened in any graphic software. So now you have to set these parameters are the image name and output location of folder. You have to left click on to save this image, and this image will be saved. Now you can add this georeferenced image in your window. You can see that in the tutorial folder, we rectified the image on the three known points, on the basis of three known points, and you can add this image. Now you can see you can remove the raw image. Now this image is rectified, and we can use this image for further details or to develop any spatial database or any other research work. This today we performed the we have to save this task also. Just today we performed the image rectification lab, and that is mostly useful for the BS level students of any discipline related to geography or agriculture, geology, engineering, or mining, or any other discipline, botany, zoology. Every student can get the benefit of any study area which he or she is using to develop any spatial database. In the next lab, inshallah, we will try to develop the shape files, how to create the shape files to develop a spatial database. Thank you for watching this lab. You can save and close this lab. Now you can save this task. We will continue this task in the next class. Good morning. I'm going to start the geo image rectification. How can we record the image from a satellite?